All right. Where do we want to start?
So number 4.
Okay. So there's 3 types of factoring. Let's talk about them. There's greatest common factor. There's dopes. And these are the order you want to look for them. Dopes means difference of perfect squares. And the final one is if you have a typical quadratic, then you factor it like a quadratic. A typical quadratic would be number 5.
Okay.
Okay? So, on number 4, that's not a typical quadratic. Is there a greatest common factor that we can take out of number 4?
Six.
Well, that's the highest number we could take out. There's a variable we can take out also.
Oh, x squared.
Yeah, always consider both. That's the greatest common factor. And what's left behind?
So 4 minus.
It's got to be 4x squared. Remember, these two numbers have to multiply together to give you what you started with.
Oh.
Here's what you do. Once you figure out your greatest common factor, you just divide both terms by it. And that's always what's left. So what do you get when you divide 54x squared by 6x squared?
So 9x squared then?
Minus 9. Just 9. And if you, in other words, if you want to check to see, and you should always do this every single time, is after you've factored it, multiply it back together again. That times that is 24x to the 4th. That times that is minus 54x squared. That's what you started with. Okay?
Okay.
Now, after we took the greatest common factor out, we can see that the next check would be, do we have any difference of perfect squares? We do. 4x squared is a perfect square, and 9 is a perfect square. And they are being subtracted.
So it's...
What's it going to be?
So 2x.
In other words, we're going to take the square root of that, which is 2x.
Yeah.
And we're going to subtract the square root of that, which is 3.
Right.
And then the other term, you don't even have to think about. It's just the conjugate of this.
So 2x plus 3.
And there the thing is fully factored. So on that one, we had to use both greatest common factor and dopes. I'm going to leave those there for a second, just so we'll know what order you always want to do these in. You always want to check for greatest common factor, and it's important to do them in the right order, because sometimes if you take a greatest common factor out, it leaves something quite simple.
Okay.
Now, 5 is their greatest common factor.
Right. So the dopes.
Now, hold on. Let's start with GCF. For 5, is there a greatest common factor?
No.
Correct. Is it difference of perfect squares? Difference of
Yeah.
difference of perfect squares, usually you have something like x squared minus 9. In other words, you're missing the x term. Okay?
Okay.
And that's almost always true with difference of perfect squares. The first one was actually a little bit of a hard example of it. But this one does not have any dopes,
Okay.
which means we're stuck with factoring it the normal way.
Okay.
And how do you do it? Work me through it step by step. Don't give me the final answer. Tell me what the first thing you got to do is.
So it's
First step is to split those x's up.
so x minus 1.
First step only. X
Okay.
is x. Now, second step is determine both signs. Do not try to figure out the answer. Just try to figure out what both signs have to be.
So negative.
They have to be opposite. If they were both negative, this would not be a negative 12. It would be a positive 12. If they were both positive, that would be a positive 12. The only way you can produce a minus 12 is if the signs are opposite.
Okay.
So that's step 2, always. And I can't stress how important it is to do these step by step. If you do, these will be a piece of cake. Factoring is not a problem if you follow these 3 or 4 steps. Now, we've done the first 2 steps. The third step are factors of that number that subtract, because that's a negative sign, to the coefficient in front of the x term, which is a 1. So what factors of 12 subtract to the number 1?
12 and 1. Oh, subtract.
Subtract to the number 1. 12 and 1 subtract to 11. 6 and 2 subtract to 4.
4 and 3.
There you go. Now, take the larger of those factors, 4, put it with the sign of the middle term. The sign of the middle term is negative. So the 4 goes with that. The 3 goes over there. And that's how you do them. And that's really rather straightforward and simple. Now, we'll do it over and over again here. But that's the answer to number 5.
Okay.
Now, 6. 6, any greatest common factor?
Yes.
What is it?
So the 2x squared.
Remember, the greatest common factor has to divide into all 3 of these terms evenly.
Oh, okay. So
I didn't want to open it, but it just didn't seem.
There is no greatest common factor.
yeah.
You can't divide all 3 terms by a number. You can't divide all 3 terms by a variable. So it's not greatest common factor. Is it dopes?
Yes.
Now, remember, dopes rarely has this middle x term. You have to have the difference of perfect squares. If I said x squared minus 8, that is not dopes, because 8 is not a perfect square. If I said x squared minus 9, that is dopes, because 9 is a perfect square number. If I said x squared minus 25, that's dopes, because 25 is a perfect square number. So you can only use dopes if you have perfect squares.
Right?
Okay.
Okay. So again, it's a standard factoring problem. Only this is not first degree, this is second degree. And I'll explain the difference as we do it. First step, it's the same as the first step of the easy ones. What is it?
So,
What was the first step on this easy one over here?
the x's.
Split up the x's. Same first step on the harder one. Split up, only this time they have to multiply to 2x squared. So what am I going to put here? It's not x and x, because x and x multiplies the x squared. So whatever I put here, I have to multiply to 2x squared.
No. I asked you if they know that.
That's what it has to be.
Oh, yeah.
You have that.
Always split up the x's. In other words, you never would have an answer of 2x squared times 1. Just not the way you do it. Okay? In other words, always splitting the x's out.
Oh, okay.
Now, what's the next step? Still the same.
The
No, I want to say
signs, so it's
Signs have to be.
positive.
Yeah. In other words, we know they have to be the same because that's the only way you can get a plus sign there. And they're both positive because that's plus. So we know it's plus, plus.
Right.
Now, you can throw your rules out the window for the last step. We cannot say factors of 4 that add to 9. We cannot say factors of 4 that subtract to 9. Those rules you can't use when you're on these second degree quadratics, what I call a second degree quadratic. You just have to do a little trial and error. Well, what are factors of 4? We got 4 and 1 and 2 and 2. So those are our only choices. As I tell everybody, start out with the two numbers that are closest together, 2 and 2.
Okay.
That produce a middle term of 9x. That is the question. Remember, the middle term comes from those two multiplied together plus those two multiplied together added together. In other words, it's the O and the I of FOIL. So that produces a middle term of 6x, right? Because that would be 2x, that would be 4x, add them together, I get 6x. So that's not right. And we really can't try any other combination except 4 and 1. So let's try 4 and 1. This is a trial and error procedure. And you'll quickly find out that I need to put the 4 over there and the 1 there. Now, that gives me plus 1x. That gives me plus 8x. Add them together, I got plus 9x. That is my middle term. I have factored it correctly. And you can see that these are quite a bit more difficult. The first type, the elementary ones, those are elementary. In other words, I can just apply 3 rules to this one over here. But when I have a little bit of a harder one, where there's a coefficient in front of the x squared, then it's a trial and error process.
Okay.
Okay? This number 7, that's a harder one. In other words, the coefficient of the x squared is not 1. First of all, is their greatest common factor. Always go through this step-by-step process.
Yeah, no.
No, there isn't. There's no number that divides into it. There's no letter that divides into it. All 3 terms. Is it dopes?
No.
Remember, difference of perfect squares usually is just two terms. It's x squared minus 49. It doesn't usually have this x in it. In fact, never. Okay, so it's immediately not doped as soon as you see an x, which means we have to factor it. Okay?
Okay.
Now, first step.
So it's x on both sides.
Would that multiply to 9x squared?
So 9x and then x.
One way to do it. Here's the way I would try to do it. In other words, I use the same rules. I take the two numbers that are closest together. 3 and 3 are closer together than 9 and 1. You know what I'm saying?
Yeah.
Just as the first step. The answer may indeed be 9 and 1, but we don't know it yet. We're going to have to experiment. What are both signs?
So they are one's positive, one's negative.
No. If that were true, that would be a negative 4.
Oh, that's a positive.
So they both have to be the same. They don't have to both be plus, but they have to be the same. And as long as I know they have to be the same, I look to the sign on the middle term, which says plus. Now I know they have to both be plus. Okay?
Okay.
Now, factors of 4. I assume that's a 0 on the other side of the equation, equal sign there.
Yes.
Yeah, I don't know what else it could be. I can see half of it, but it has to be 0. So what factors of 4 should I start with?
So
Remember, it's a trial and error. There's only two sets. There's 4 and 1, and there's 2 and 2.
So 2 and 2.
Always start with the two that are closest together and see if that works. Does that work? Does that produce 12x as a middle term?
Yes.
Bingo, we got it on the first guess. If it would not have, then I go back and I try 4 and 1. If that doesn't work, I might have to go back and split up my x's as 9x times 1x. So these things become increasingly more difficult the more factors there are of these numbers.
Right.
That's why I call these second degree as opposed to first degree. First degrees are easy. You can just apply the rules. Now, number 8. What do I need to do to that before I can figure out how to go forth?
You need to put into standard form, or at least equal to
Which
0.
is what?
Oh, like what standard form is?
Well, I got to move this 50 to the left side. In other words, I got to get 0 on the right side, just like number 7 had 0 on the right side. Once you get 0 on the right side, then you can factor it. I get 0 by subtracting 50 from both sides. So I end up with x squared plus 3x minus 54 equals 0. Now this is an elementary factoring problem. So you tell me every step.
So x on both sides. Okay, so that's negative. So one side's positive, one side's negative.
Correct. And then what's the third rule?
So it's 3 and 1 because...
No, it's got to be factors of 54. In other words, the last two numbers that I write have to multiply together to 54.
Okay.
And I got to subtract to 3. So let's find all factors of 54. What's the first step?
divide by 2.
Okay. Which means I got to multiply that one by 2. So those are two factors. Now I can't divide 27 by 2. What can I divide it by?
3.
So I'm going to take a third of that one, which means I got to multiply this one by 3 to get that. Now I think I just found my answer. I was looking for factors of 54 that subtract to the number 3.
Hi.
The 9 goes with which number and the 6 goes with which number? Larger factor goes with the sign of the middle term. The middle term has a plus sign on it. So the 9 goes there, the 6 goes there. Hold on, I'm going to let my dog in. He's howling. Come on in. Well, you want to come in? I'm closing the door, though. You're stuck in here. Okay, everybody lay down. So because it was a elementary quadratic, then it just required those 3 steps. No trial and error, just do those 3 steps.
Okay.
The next one, number 9. Again, whenever you have any quadratic, your first step is to get everything on one side, get 0 on the other. Always. And get your coefficient to be a positive number that's in front of the x squared. You don't want that to be a negative number. So when you get everything on one side, choose a side where the x squared has a positive coefficient. You with me? In other words, I could have moved the right side to the left, or I could have moved the left side to the right. I didn't want to move the left side to the right because that would have given me a minus 3x squared.
Right.
Move the right side all to the left. Now, again, this is a secondary quadratic merely because this coefficient is not 1. But the first couple of steps are still the same. What's the first step?
So there's a 3x on one side and then a normal x on the other.
Okay, what's the next step?
They're opposite signs.
Unfortunately, in this case, plus minus is not the same as minus plus. In other words, whenever the coefficients in front of the x are different, then you have to list both options. You have to consider both plus minus and minus plus. Now, let's talk about factors of 24. Let's just go figure out what they are because there's a lot of them. What's another set?
So 4 and 6.
Do this methodically. By methodically, I mean always start with 24 and 1, and then cut that in half if you can, which means you got to double that, and cut it in half again if you can, so we do get to that, and then cut it in half again if you can. So you
3, 8, yeah.
So all of those are factors, and I can no longer cut that in anything, half or thirds or fourths or anything.
Okay.
Okay, so I'm looking to, by trial and error, choose one of these sets of factors and see if it produces. My entire goal is to produce that middle term of minus 6x. Well, I got a lot of things to choose from. Which factors am I going to start with?
6 and 4.
Always. Just 6 and 4. In other words, this is strictly trial and error at this point. Now, what does that produce as a middle term?
So
use the double smiley faces. What's the inner smiley face equal to?
So 6x plus. So 6x.
Okay. What's the outer smiley face equal to?
12x.
Minus 12x.
Oh, yeah.
You got to multiply 3x times minus 4. Add those together, you get minus 6x. That's the answer. First time. I don't want to make it that easy. I want to show you what to do if I hadn't been so lucky. Let's say that I'd have started down here with 6 and 4. Okay? Because you're not always going to get lucky enough to get it the first time. However, there are some shortcuts. If I started this way, well, then that's minus 6x. That's plus 12x. Add them together, I get a plus 6x. Well, that's not right, but it's the right number. It's just the wrong sign. Well, I know how to get the right number and the right sign. Just move the 6 up to the plus sign and move the 4 up to the minus sign. And that's always going to be your answer. Now, if this number is not 6, then I got to try a whole different tactic. I either got to switch the 6 and 4, or I got to go try 2 other numbers. But if you get the right middle number but the wrong sign, then it's easy. Then you just take the same 2 numbers and move them to the other sign.
Okay.
And that gives you the right answer. All right.
All right.
That was
number 9.
Well, let's go back and look at number 9, because I made a mistake here. I didn't get the wrong answer. I just got it in a very difficult way. What did I forgot to look for when I started this problem?
Oh, greatest common factor.
What is it?
3.
So I can simplify this tremendously by taking out that greatest common factor. And now I have to just deal with an elementary quadratic. So I still got to carry forth the 3, but now when I factor that, I'm going to get x minus 4 and x plus 2. And that's my correct answer. Now, the answer I got before, I think, was 3x plus 6 times x minus 4.
Yeah.
You could actually factor that further down into this, but you always want to factor it all the way. In other words, before I got 3x plus 6 times x minus 4. Well, that really wasn't a final answer because I can take a 2 out of this. Excuse me, I can take a 3 out of that, leaving x plus 2 times x minus 4. That's actually the final answer, regardless of how you do it. But this is an excellent example of where if you take a greatest common factor out first, you're left with a much easier quadratic to factor.
Okay.
That's why you always check greatest common factor first, even though I violated it on myself here. First step on number 10.
So it's a 2x on one side and then an x on another.
Hold on. We got to get everything on one side first. Remember, you got to have 0 on the other side before you can start factoring.
Right. Okay. So it's 2x squared plus 7x plus 6.
There's our quadratic that we got to deal with. And even though I call this second degree, it's not that hard because there's only one choice on how to split the x's up. It's not multiple choices like there was when I had a 9x squared. This can only be split up in this manner. What are both signs?
Positive.
What are the most likely factors that I'm going to use?
3 and 2.
Okay, let's try it this way. Does that produce a correct middle term?
No.
Let's try it this way. Does that produce a correct middle term?
Yes.
That's my answer. 2x plus 3 times x plus 2.
All right.
Okay. 11. Again, even though we don't see a constant, so we're not going to use a standard quadratic factoring, we still want to get everything on one side. In other words, we want it to get to be the form, well, it's going to be its own form, but we're going to subtract that 5x. So I'm going to have x squared minus 5x equals 0. Now, is there a greatest common factor?
Yeah, 5.
Don't forget the variable.
X.
5x is the greatest common factor. Remember, I'm looking for something that is the largest possible thing that divides into both terms evenly. What does that give me left over?
So that's 2x minus 2. Or, sorry. Yeah, 2x minus 1.
See why it's 1?
Yeah.
Remember, when I multiply it back together again, I got to get back to what I started with. Well, that
Right.
times that is 10x squared, and that times that is minus 5x. And that's the final answer. That does not factor anymore. So this was strictly a greatest common factor problem.
Okay.
Always why you start there. All right. Look at number 12. I assume we just want to do all of these in order?
Yes.
Okay. So, have we done transformations before?
I think so.
Okay. Well, they give you the parent graph. What you have
Right.
to do is figure out what is being done to the parent graph to give you that. And in this case, there's 1,
So
3, 4 things being done.
it is
Always left to right.
a vertical shrink by 2, I think.
Verticals, first of all, start with the negative sign. Always start far left and go to the far right.
So it's a reflection over the x-axis.
Okay. Second, what's the 2 do? Vertical or horizontal?
Vertical.
Stretch or shrink? Stretch if that number is greater than 1 by 2. So I'm stretching everything by a factor of 2. Okay. What's the minus 3? Is that horizontal or vertical?
It is a horizontal.
Because it's inside the function. All vertical stuff is outside the function. All horizontal stuff is inside the function. What is it? A horizontal, is it a stretch, a shrink, or a shift?
A shift.
Which way?
Right.
Right by 3. Finally, we have a plus 8. Is that vertical or horizontal?
Vertical.
Is it a shift, stretch, or a shrink?
A shift.
Anything that's being added or subtracted is a shift. That's why. And it's up 8.
Yep.
In other words, this 2 was a multiplier. That means
Right.
it's either a stretch or a shrink. This 3 was being subtracted. That means it's a shift. That 8 is being added. That's a shift.
Okay.
Rewrite in standard form. How do I do that?
So, distribute the 2 first.
Actually,
Or negative.
you want to square. In other words, you want to use PEMDAS. You want to do the exponential part first.
Okay.
Because
so distribute
that leading 2 is not being squared. The only thing that's being squared is x minus 3. So what's x minus 3 times x minus 3?
X squared plus 9 x.
That's next. That's minus 3x. That's next. That's minus another 3x. That times that is plus 9. So that's x squared minus 6x plus 9. Okay?
Okay.
So I'm going to write that. X squared minus 6x plus 9. That whole thing still has to be multiplied by minus 2, and then I have to add 8. So now distribute the minus 2. What do we have?
So negative 2x squared plus 12x plus or minus 18.
Plus 8 gives you minus 10.
Okay.
In other words, you can combine the minus 18 and the plus 8. Okay?
All right.
So that's the same function right there as we started with. In other words, that's f of x. Is all we've done is multiplied it out and put it in standard format. Standard format being that, which is exactly what we're looking at. Now
Okay.
you want it in factored form. In this form over here, which is x-intercept format. There's really 3 formats for quadratics. There's Vertex format, which is what we started with. Then there's standard format, which is what we just turned it into. And now we're going to factor it and try to get it into this x-intercept format. And the beauty, all 3 of them have an advantage. The vertex format tells you exactly where the vertex is. If you can get it into x-intercept format, then you know where the 2 x-intercepts are, and that tells you an awful lot also. So let's try to factor this thing. What's the first thing I want to
do? So the x's are on, so it's 2x.
What's the first priority? What should we always look to do first?
Equal it to 0.
Greatest common factor.
Right.
Always start with greatest common factor. Can I pull out a greatest common factor?
2.
Let's pull out a negative 2. The reason that works better is because it leaves us a elementary quadratic. Is that the same thing?
Yes.
Okay, now factor the elementary quadratic. You can't forget the minus 2. You've got to bring it along for the ride.
So it's
pretty easy to factor. What are both signs? They're the
negative.
same. They have to be the same, but are they positive or negative?
Negative.
Because the sign on the middle term is negative. That's what you go by. So I know it's minus times minus. Well, there's not much choice on the 5s. Do factors of 5 add to the number 6? They sure do. 5 plus 1 equals 6. There's not even any choice as to where the 5 has to go, where the 1 has to go.
Right.
That is fully factored. And notice that that is now in that exact format. We've got a of minus 2. We've got one of the x-intercepts is at 5, and the other x-intercept is at 1, positive 1 and positive 5. So if I wanted to graph that, I would know that, gosh, it goes through 1 and it goes through 5. Well, I know it's a parabola and I know it opens down, so it's got to look something like this. So knowing the x-intercepts is pretty big. It's not quite as good as knowing where the vertex is, but if I want to know where the vertex is, just look there. The vertex is at 3, 8. If I look at what it said in vertex format, H and K are the vertex. So all of the various formats have their purposes.
So the x-intercept is 5?
One of them,
Or
two of them. There's one at 1 and there's one at 5. Notice this format over here is x minus p times x minus q. So p is 5 plus 5 and q is plus 1. So those are my two x-intercepts.
okay.
Okay. Question C. Find the vertex, y-intercept, and x-intercepts. Well, we just found the x-intercepts. We found the vertex because we looked at the original format, and the vertex was at 3, 8. Now, how about the y-intercept? What's the x value when you're on the y-intercept?
0.
Correct. So let's go to the function in standard format. Substitute 0 for x. What do you get for y?
Negative 10.
That's the y-intercept. In other words, the y-intercept is actually the easiest thing to find. Once you get it in standard format, that is always the y-intercept, whatever the constant is. Because when you plug in 0 for x, you take out all the other terms. By taking them out, I mean you drive them to 0. So you're left with whatever that constant is.
Oh,
Okay. So we answered C. We found the vertex, y-intercept, and x-intercepts. I got to erase what D says. Graph it with at least 5 points of accuracy. Well, how many points do we have so far?
3.
I actually have 4, because we have this y-intercept.
All right. Okay.
Well, if I know that point, I know that point, because everything is symmetrical about that line of symmetry. What's that point right there? What's halfway between 1 and 5?
3.
So if this point is exactly on the other side of that line of symmetry as this point, what are the coordinates of this fifth point over here? 6, minus 10. See why it's 6?
Oh. Yes.
It's got to be an equal distance. In other words, that distance right there is 3. That means this distance has to be 3. Well, if they're both 3, then that coordinate is 6. And because it's symmetrical, the y-coordinate is the same, minus 10. So there are 5 points. Now the last question is determine the domain and the range. Well, I can erase most of this. The domain. In fact, the domain of all parabolas is what?
0.
All real numbers.
Oh, yeah.
And the way we can tell is by looking at the graph. Remember what domain is. Domain is the allowable values for x. Well, is there any value for x that I cannot plug in? Can I put in minus 1,000,000?
No.
Sure I can. This thing goes not only down to infinity, but it goes all the way to infinity on this direction also. And it goes all the way to infinity in that direction. So the domain is all real numbers. Domain is all real numbers, meaning negative infinity to positive infinity in interval notation. And I can tell that by just looking at it. But know that that is the domain for all parabolas that are vertical in nature. The domain is always all real numbers for parabolas. Now the range is a little different. If I look at that graph, what's the bottom end of the range? Always start from the bottom.
So it's
What's that go down to eventually?
infinity?
Negative infinity.
Oh, negative infinity, right.
What's the top end of that range?
8.
Correct. Now, do I have a bracket or a parentheses next to the 8?
A bracket.
Bracket, exactly. Because it can be 8. We can see that there is a value there at 8. It's not like it can be up to 8, but not 8. If it couldn't be 8, I'd use parentheses. But if it can be 8, I got to use a bracket. And you always use parentheses next to infinities. Because infinity is not a number, it's a concept.
Okay.
Now, question F, which we just have time to do. Find all values of x for which f of x equals 6. Well, there's f of x. I'm just going to make it equal 6. And then I got to solve that equation right there.
Okay. So
what's the best way to solve that equation?
Subtract 8 from both sides.
Yeah,
so
it's not to put it in standard format and factor it.
Right.
That's the hard way to do it. Easy way to do it is because we have, well, let's just go through it and you'll see why it's easier. Subtract 8 from both sides. So now I got this. Correct?
Yeah.
Now what?
Divide by -2.
That gives me this. And now I'm going to solve this by taking the square root of both sides.
So x minus 3 equals plus or minus square root of 1.
Which is 1.
Right.
Now, what's the total answer?
X equals 3.
Plus or minus 1.
Right.
What two answers does that give you?
3 plus 1 and 3 minus 1. So 3 plus 1 is 4, 3 minus 1 is 2.
Those were the same two answers we got when we put it into that x-intercept. No, they weren't. Oh, it was a totally different question. In other words, when we were solving for the x-intercepts, f of x was equal to 0, not 6. So when they ask us what values of x makes f of x 6, It's these two. 4 and 2 both do. I could substitute 4 for x or 2 for x, and that expression would equal 6.
Okay.
Okay? That's a good place to stop. I don't think we have enough time to do the next problem completely, so we probably don't want to get started on it either.
Yeah, that's fine.
Okay. You can do it on, oh, this is Thursday. Next Tuesday, I suppose, or whatever. You probably have additional stuff by then, but that's the way it goes. Demetrius,
Yeah.
I'll talk to you next Tuesday.
Yep, you too.
All right.
Thanks.
Bye-bye.